Welcome to Episode 1, The Beginning and Formation of Divine Land. Bharatvarsha, since the dawn of civilization, has been known to mankind as the vibrantly thriving epicenter of culture, wisdom, spirituality and knowledge. Through this series, we dedicate ourselves to put forward the vast enduring legacy of Vedic culture and history of ancient India. Long before those battles, long before every monarchy, we shall come to know the profound origin of India and explore the Indic heritage alongside ancient Indian civilizations. Uttaram yat samudrasya himadresya vata dakshinam varsham tadam bharatam nama bharti yatra santati. अर्थात समुद्र के उत्तर में और हिमालय के दक्षिण में जो देश है उसे भारत कहते हैं तथा उसकी संतानों या नागरिकों को भारतीय कहते हैं. Brief history of Earth and Solar System. Before we understand the complex ancient history of Bharatvarsha, first we need to understand the timeline of Earth itself. History of the solar system. In order to begin with the formation of Earth, we need to understand the history of our solar system. Our solar system was formed with the birth of the Sun about 4,568 million years ago. Probably a stellar molecular cloud of hydrogen and helium-based nebula would have given birth to the Sun. A cloud so large spanning several light years across the interstellar space. Impressively enough, it took about 5 to 7 billion years for the heavy elements to come into existence, since the occurrence of the Big Bang about 13.8 billion years ago. The atoms of hydrogen and helium gases formed the heavy elements and space debris. Later, strong forces of gravitational attraction resulted in increase of density and nebulae formation. Our Sun is a G-type main sequence star. It was not formed all of a sudden, but rather transitioned through a series of star life cycle phases, the earliest being protostar phase. It has a solid core and enormous reserves of heavy hydrogen gas under high pressure due to its own gravity. This results in the occurrence of nuclear fusion. Protoplanetary disk and formation of Earth. The protoplanetary disk refers to the remnants of clouds and space debris which surrounded the newly formed protosun in a disk shape. The Sun was formed about 4.5 billion years ago. However, the molecular stellar clouds surrounded it for several million years, before finally getting arranged into a disk shape of clouds which is termed as the protoplanetary disk. It is so named because those clouds were responsible for forming the planets around the Sun and all the other cosmic objects of the solar system. With time, the density of gases decreased and the solid debris coagulation increased, resulting in formation of several planets with their respective moons, asteroids, etc. Our planet Earth was formed soon after the formation of protoplanetary disk, about 4.3 billion years ago. As per scientific research, new data reveals the CMB radiations also played a major role aligning the protoplanetary disk. The ionized clouds resulted in a process known as stellar bombardment of stellar debris, forming other meteorites and asteroids all along orbiting the Sun. It's interesting to note that all the planets were formed at different stages, earlier forming a protoplanetary phase. Our Earth has had about 4 different eras of development before it became like what it is as of now. Vedic reference to expansion of space and Hubble limiter law. The third shlok of chapter 10 verse 90 of Rigved clearly tells us about the principle of space expansion. The mantra Ekoham Bahushyam suggests the idea of expansion of interstellar space and moving away of cosmic objects with respect to one another along with the time. The Purusha Shuktam also refers to the limited range of observable universe, which is referred to as Shara Virat in Sanskrit. This is due to the ever-expanding universe at the speed of light, which is the reason why the boundaries of the observable universe remain constant. In modern physical laws of astrophysics and cosmology, one can observe the references similar to what Hubble limiter law suggests, which is what the cosmic objects are moving away at speeds proportional to their distance between them. History and timeline of Earth. The geological timeline of Earth spans over the period beginning about 4.5 billion years ago till present day. The Earth as we see today has undergone dramatic changes from the moment it was created, undergoing biological explosions, heavy bombardments, ice ages and whatnot. The entire timescale of Earth has been divided into 2 super eons, which are Precambrian and Cambrian. The Precambrian consists of Hadean, Archean and Proterozoic Eons. whereas the Cambrian Eon consists of only Phanerozoic Eon. We shall have a detailed study of each of the eons. The first one is the Hadean Eon. The Hadean Eon, which lasted for 4.5 to 4 billion years ago, saw Earth's formation and to early development. Intense meteorite bombardment and volcanic activity characterized the unstable, molten surface. The Moon formed from debris after a Mars-sized body called Theia collided with Earth. The Earth's atmosphere, created by volcanic outgassing, was composed of water vapor, carbon dioxide, nitrogen, methane, and ammonia with little to no oxygen. As the Earth cooled, water vapor condensed to form the first oceans. With the end of this eon ended the late heavy bombardments. The first sign of life probably have developed in the vast oceans, forming simple biomicromolecules as per the biochemical theory of evolution and abiogenesis. The second eon is Archean Eon, which lasted for 4 billion years ago to 2.5 billion years ago. The Archean Eon had about 4 different eras, which were Eoarchean, Paleoarchean, Mesoarchean, and Neoarchean era. Characterized by the formation of the planet's first stable continental crusts, the Archean witnessed intense volcanic activity and the gradual cooling of Earth's surface. The atmosphere was primarily composed of methane, ammonia, and other gases with little oxygen. During this time, the earliest non-life forms, predominantly the prokaryotic microorganisms like bacteria and archaea, emerged in the primordial oceans that started in the first photosynthetic processes. The tectonic activity led to the formation of the first supercontinents like Ur, Valbara, and Kenorland. The Archean set the stage for the subsequent Proterozoic Eon, shaping the early biochemical and geological framework essential for the development of complex life. The third eon is Proterozoic Eon, which lasted from 2550 to 541 million years ago. The Proterozoic Eon, spanning from 2.5 billion to 541 million years ago, was a transformative period in Earth's history. Saw the stabilization of continental cratons and significant atmospheric changes, most notably the Great Oxygenation event around 2.4 billion years ago. This surge in oxygen, produced by photosynthetic cyanobacteria, green sulfur and purple sulfur bacteria, profoundly altered the planet's environment and set the stage for more complex life forms. The eon is marked by the emergence of the first eukaryotic cells and the appearance of multicellular organisms. Geological activity during this time led to the assembly and breakup of supercontinents such as Rodinia and Pannotia. The Proterozoic Eon also experienced extensive glaciations, including the snowball Earth events. By the end of this eon, early life began to appear in eukaryotic forms and higher life forms such as animals, setting the foundation for the Cambrian explosion and proliferation of diverse life forms. The Cambrian explosion, occurring about 541 million years ago, marks a pivotal event in the history of life on Earth. It was a period of rapid evolutionary development where most major animal phyla appeared in the fossil record over a relatively short geological time span. The causes of Cambrian explosion are still debated, but many factors include to increased oxygen levels, genetic developments like the evolution of Hox genes, and ecological interactions such as predation. Phanerozoic Eon. The Phanerozoic Eon is the current eon in the geological timescale, spanning from about 541 million years ago to the present. It is characterized by an abundance of fossil evidence, which is why it's named Phanerozoic, meaning visible light. The Phanerozoic Eon is divided into 3 major eras: the Paleozoic, the Mesozoic, and the Cenozoic. Each of these eras are further subdivided into periods, marked by significant geological and biological events. During the Paleozoic, which lasted from 541 to 251 million years, many modern groups of life came into existence. Life colonized the land, first plants and then animals. 2 major extinction events occurred. The continents formed at the breakup of Pannotia and Rodinia at the end of Proterozoic slowly moved together again, forming the supercontinent Pangaea in the late Paleozoic era. The Mesozoic or Middle Life era lasted from 251 to 66 million years. It is subdivided into Triassic, Jurassic, and Cretaceous periods. The era began with the Permian-Triassic extinction event, which is the most severe extinction event in the fossil record, which resulted in the extinction of 95% species on Earth. It ended with the Cretaceous-Paleogene extinction event, that wiped out the dinosaurs on account of the Chicxulub meteorite event. It is also known as KPG extinction event, which marked the end of the Cretaceous period and along with it, the end of Mesozoic era. The Cenozoic era, often referred to as the age of mammals, spans from about 66 million years ago to the present. It follows the Mesozoic era and is divided into three periods: the Paleogene period, the Neogene period, and the Quaternary period. This era is marked by significant geological and climatic biological changes, including the rise of mammals and birds to ecological dominance and evolution of humans. Plate tectonics and history of continents. Precambrian continents. These were the continents that came into existence before the Cambrian explosion. The first proposed continents were Ul, Varvara, and Kenorland, which were formed during the Archean Eon about 2.3 billion years ago. During the late Proterozoic, the three continents formed the Rodinia and Pannotia. The shape of Pannotia was much like the Pangaea, which formed during the late Paleozoic era of Phanerozoic Eon. Post-Cambrian continents. Continents that formed in the Phanerozoic Eon are termed as above. During the late Paleozoic era, Pangaea formed through the remnants of Rodinia and Pannotia, which is around 330 million years ago, during the Carboniferous period of Paleozoic era. It was surrounded by the Panthalassic Ocean on west and by the Tethys Sea in the east. During the Mesozoic era, which was from 251 to 66 million years ago, the Pangaea had already started to rift apart. The Triassic period of the Mesozoic era witnessed the bifurcation of Pangaea. During the Jurassic period, the Laurasia and Gondwana land became prominent. During the Cretaceous period, which was from 145 to 66 million years ago, the Gondwana land started to disintegrate into Australia, Antarctica, and India. Later in the Cenozoic era, during the Paleogene period, the Indian tectonic plate started moving northwards nearly about 66 million years ago. The Indian plate has undergone significant tectonic activity due to plate tectonics, particularly since it broke away from the ancient supercontinent of Gondwana around 120 million years ago. Initially, the Indian plate moved northward at a rapid pace of about 15 to 20 cm per year. This movement led to the eventual collision with the Eurasian plate around 50 million years ago. This collision is responsible for the formation of Himalayan mountain range and the Tibetan plateau. The ongoing convergence of these plates continued to push the Himalayas higher, contributing to frequent earthquakes in the region. Thanks for watching till the end of this video. I hope that you enjoyed watching it and found it to be quite informative. If you did so, please consider subscribing and hitting a like. In the next episode, we shall discuss about the advent of first humans in the Indian subcontinent and study the effects of Toba volcanic eruption along with the prehistoric ages of civilization of Bharat. I have attached the link of reference for some of the fossil evidences which were found all over the Indian subcontinent for you to check them out yourself. I'm pretty sure that you guys would certainly like that. Thank you.